Hello and welcome to Lesson 2.3 where we're going to be talking about conditional statements. Now conditional kind of refers to, you might think of a condition that needs to be met in order for something else to happen, and that's going to be the main idea here. Previously, we used logic and Venn diagrams to determine truth values of negations, conjunctions, and disjunctions. We're still going to be talking about truth values, but we're going to talk about if-then statements, and these are statements that can be what we call conditional statements. We will also look at writing the converse, inverse, and contrapositive of if-then statements. So let's talk about what an if-then statement is. You should have read this and written it down in your vocab so far. But just to recap, an if-then statement is anything in the form if statement P, then statement Q. We use this symbol notation to symbolize that, and we read this if P, then Q. We imply the word if before this P. This arrow can be read as the word then, and then Q, and then we also could read this as P implies Q. The arrow could mean the word implies also. Then every conditional statement has two parts, a hypothesis and conclusion. This first part, hypothesis, won't always be written first in the sentence. There's different ways of writing these sentences that rearranges that order, so we need to recognize that the hypothesis is that condition that has to be met, and so we'll always follow the word if. The hypothesis is the part following the word if. The conclusion is the part following the word then, or wherever that word then should be in the sentence. So let's start by identifying hypothesis and conclusion of a conditional statement. We have our conditional statement: if a polygon has 6 sides, then it is a hexagon. Remember, hypothesis, part P, follows the word if. There's if, and so our hypothesis is a polygon has 6 sides. So write hypothesis, a polygon has 6 sides. Then the conclusion is the word or the phrase that follows the word then. It is a hexagon, then is our part Q, the conclusion. Alright, now in the next part of this example, you'll notice they don't exactly word the sentence the same way. Let's read this sentence. Tamika will advance to the next level of play if she completes the maze in her computer game. That condition that has to be met, the thing she has to do first before getting to the next part of this sentence, is completing the maze in her computer game. It's still the part following the word if. It's just that the word if is now in the middle of your sentence. So the last part of the sentence, she completes the maze in her computer game, is actually the hypothesis. And now once she completes the maze in her computer game, then Tamika will advance to the next level of play. So when I rearrange the ideas in that order, you'll notice that the conclusion is that she will advance to the next level of play. So the conclusion and the hypothesis don't always go hypothesis before conclusion. It's just about how the sentence is worded. So kind of think back to reading it out loud and listening to how it sounds. Now, to move on to example 2a, we are going to be given certain statements that are conditional, but they're not written in if-then form, and so we need to be able to write them in if-then form. So here's what we have. A 5-sided polygon is a pentagon. We need to be able to write that in the form if some statement P, then some statement Q, where P is your hypothesis and Q is your conclusion. And so we need to know what those two parts are. So we have two ideas here in this sentence. A 5-sided polygon, or a polygon with 5 sides. We might need to word it that way to have it sound better and make sense in the sentence. And then a pentagon. You might think, well, those are the same thing. Well, that's what this is saying to us, that that's what a 5-sided polygon is. But there's still two parts to that. They use two separate phrases: 5-sided polygon and a pentagon. So we have to be able to put those in if-then form. So I can call this first one my hypothesis, because if we know that a polygon does have 5 sides, then we know it's a pentagon, and there's a conditional that I just said, but we're going to write that out. 5-sided polygon. So our hypothesis could be that a polygon has 5 sides, or we could just write 5-sided polygon, but we would have to rearrange that wording to something like this, as you'll see when I write the conditional. Then the conclusion is a pentagon. So our conditional could be this. If a polygon has 5 sides, then it's a pentagon. Ignore the little scribbles. If a polygon has 5 sides, then it's a pentagon. That could be our conditional statement. All right. Let's see if you can try part B on your own. Now, it does say to write the correct form of an if-then statement, and correct meaning it needs to still have an accurate meaning. If we said an angle that measures 45 degrees is an acute angle, I can't say if it's an acute angle, then it has a measure 45 degrees, because not all acute angles have a measure of 45 degrees. But our hypothesis really needs to be this first part. Then our conclusion is that it's an acute angle. So go ahead and write that in if-then form, and we'll see what we should get. Alright, if you need more time, pause the video. Otherwise, this is what we should have for a conditional statement. If an angle measures 45 degrees, then it is an acute angle. You could also say that an angle is acute if it measures 45 degrees. Alright, now we're going to talk about determining truth values of conditional statements. And I need you to understand me when I say it's not always about what makes sense. It's about a specific truth value for P and Q, the two parts, hypothesis and conclusion. Okay, so it's best to think of this as this kind of a situation. Determine whether the father in this situation lies to his daughter in each of these 4 cases. Here's what the father's statement is. If you clean your room, then you can go to the movies. Situation 1, the daughter does clean her room and she went to the movies. Well, we can verify that the father was telling the truth. She met her condition. She received the reward that he said she would get. So the father was telling the truth. However, situation 2, she cleans her room and she doesn't get to go to the movies. He says no. Well, that means his previous statement was a lie for the purposes of this argument. So, because she met her condition, the conclusion of that statement was actually false, and so we can say that's a lie. But in the last 2 situations, she doesn't clean her room. First situation, she does not clean her room, she goes to the movies. Do we know whether or not the dad was telling the truth or not? No, because she didn't do her part. Since we can't say whether the dad was telling the truth or not, we always assume truth. We assume the dad was telling the truth. She didn't clean her room. She went to the movies anyway. It doesn't matter. She didn't clean her room. Same situation here. She did not clean her room, but she doesn't go to the movie. It still doesn't mean the dad was lying or telling the truth necessarily, so we assume truth. It's kind of the same concept of innocent until proven guilty. So what we gather from this then is that in order for a conditional statement to be true, your hypothesis must be true and conclusion is true, or your hypothesis is false. We can make a quick truth table for hypothesis and conclusion to verify that. If the hypothesis is true and conclusion is true, your conditional is true. If the hypothesis is true and the condition or the conclusion was false, then your if-then statement is actually false. And what we notice is that's the only way to prove that a statement is false, is if your conditional statement has a true hypothesis and false conclusion. Again, remember, it's not about whether the argument makes sense. Analyze the form of the argument to determine the conclusion, whether or not it follows logically from the hypothesis. So we're going to be determining truth value of some conditional statements. So here's what we have. We want to determine if this is a true statement overall. First, we need to identify the hypothesis and conclusion. Our hypothesis last month was February. Conclusion this month is March. So let's try and think about the truth and false values of our statements. Let's think of a time of year when last month was February. Well, the only time when the last or previous month was February is when you're in the month of March. So this is a true conditional because our hypothesis is true, which leads to a true conclusion. Now let's try part B. When a rectangle has an obtuse angle, it is a parallelogram. We could also say if a rectangle has an obtuse angle, then It is a parallelogram. Our hypothesis is a rectangle has an obtuse angle. Our conclusion is it is a parallelogram. Well, let's think about the hypothesis. A rectangle has an obtuse angle. If you really think about that, a rectangle, 4 sides, but we know each angle is a right angle in a rectangle. So can a rectangle have an obtuse angle? The answer is no. So our hypothesis is false. Anytime our hypothesis is false, we must assume that the overall statement is true because, if you remember back to our example, we cannot prove that it is a lie because the hypothesis cannot be satisfied. So we can't think of a situation where we have a rectangle with an obtuse angle, so there's no way to prove that it's not a parallelogram. Since our hypothesis is false, our conditional is true. All right, we're going to talk about examples 3, C, and D in class. We'll talk more about truth value of conditional statements to clear that up. But we do want to move on ahead to talking about the converse, inverse, and contrapositive of conditional statements. So if we have our original conditional statement, if P, then Q, the converse of that exchanges the hypothesis and conclusion. It's taking the opposite logic. If Q, then P. So here's your example. If our original statement is if the measure of angle A is 35, then angle A is acute. The converse is to say if angle A is acute, then its measure is 35. You exchange hypothesis and conclusion. Inverse is where we negate both hypothesis and conclusion, but we leave them in the original order. And then the word contrapositive is where we negate and change the order, and we get truth values that match up to those. The concept of logically equivalent statements state that a conditional and its contrapositive are logically equivalent. So if the conditional is true, the contrapositive is true. If the conditional is false, contrapositive is false. The converse and inverse are also logically equivalent. And so if we go back to look at this, if our original statement is true, then this is true. These are logically equivalent. If our converse is true, then our inverse is true. And the same works for false for both of these. So let's try practicing creating some converses and inverses. So here's what we have. We have a scientific explanation that bats are animals that can fly, and these are facts we're basing this on. Bats are not birds, they are mammals. Bats have modified hands and arms, they serve as wings, they are the only mammals that can fly. So our statement is that bats are animals that can fly. Well, bats are animals. They are mammals. Mammals are kind of animal that can fly. They are the only animals that can fly. So we're going to write the conditional, converse, inverse, and contrapositive of that statement. So we have to be able to write this as a conditional statement. So bats are animals that can fly. So our conditional might look something like this. If an animal is a bat, then it can fly. And that comes from our scientific statements here that they are mammals, and mammals are kind of animal, and they can fly. So the truth value of our conditional is true. If we have a bat, we know it can fly. The converse is where we will exchange the hypothesis and conclusion. Your hypothesis here is that an animal's a bat. It can fly is your conclusion. So we're going to exchange those. We're going to say, if it can fly, then an animal is a bat. Or you could also say, if an animal can fly, then it is a bat. We'll talk about truth and false values of these in just a moment. Let's go ahead and talk about the inverse. Inverse goes back to the original order, and we simply negate each of these. So this is what your inverse will look like. If an animal is not a bat, then it cannot fly. Again, we went back to our original order of hypothesis and conclusion, and we just simply negated both of those by adding the word not. And then contrapositive is where we flip the order and negate both statements. It's like taking the converse of the inverse or inverse of the converse. And this is what the contrapositive statement would be. If it cannot fly, then an animal is not a bat. Now, we remember that our original conditional statement was true. If an animal is a bat, then it can fly. Remember, conditionals and their contrapositives are logically equivalent, so I automatically know that the contrapositive is a true statement. Converses and inverses are logically equivalent